So in this video, we're going to talk about how to solve equations with rational exponents. So remember, the power property tells us that we need to multiply the exponents when raising a power to another power. Also, remember we talked about rational exponents last semester. You can rewrite rational exponents as radicals. Remember, what will happen is the numerator of the rational exponent will become the power, and the denominator of the rational exponent will become the root. Also, if you have x to the 1 over n, so where you have 1 becomes the power, remember that's just the same thing as saying take the nth root of x. All right, so now let's practice rewriting some examples. So let's rewrite this using rational exponents. So what happens here is that this 2 is going to become my numerator, and this index right here, that's going to become my denominator. So I can rewrite this as x to the 2 over 3, and that's how you rewrite it as a rational exponent. Now let's go the other direction and rewrite this as a radical. So this is x to the 1 over 4. So remember what we do when we have x to the 1 over n. This is going to become the fourth root of x to the 1, which you can basically write as the fourth root of x. So now you can go ahead and pause the video and try doing these examples on your own. So in this first problem, when we rewrite it as a radical, the denominator will become the index, and then that 3 will become our power. So we have the fifth root of x cubed. If we rewrite this as a rational exponent, remember that the power is going to become the numerator, so we have 3, and then the index will become the denominator, so x to the 3 over 4. So now let's work on solving some equations that have rational exponents. So in order to do this, you're going to start off by isolating the term that contains the rational exponent. Then you'll raise both sides of the equation to the reciprocal power and then solve for the value of the variable. So just a quick reminder about reciprocals. Remember, whenever you're working with fractions, you can find the reciprocal by switching the position of the numerator and the denominator. So to find the reciprocal of a whole number, what you're going to do is write the whole number as a fraction and switch the numerator and denominator. So here you can see the reciprocal of 3 over 4 is 4 over 3, right? We just switched the position of the numbers. If you have a whole number like 5, remember that basically means 5 over 1. So when you find the reciprocal, we just switch the positions and we get 1 over 5. So now let's try solving this equation for x. So whenever I'm working with equations that have rational exponents, I'm going to work on first isolating the term that has that rational exponent. So in this case, I want to isolate that a to the 1/3. Well, I can do that by first subtracting 11 from both sides. So when I subtract 11 from both sides, I get a to the 1 over 3 equals 16 minus 11, which is 5. Now what I need to do is I need to look at that power, right? I have 1/3, and I need to find the reciprocal of that. Well, the reciprocal of 1/3 is 3 over 1. Well, remember that 3 over 1 is just a whole number, right? That's just 3. So what I'm going to do to undo that exponent is I'm going to raise both sides to the third power. And let me explain to you why this works. Remember that power property, the a to the m to the n power equals a to the m times n. So if I take these two exponents here, okay, this 1/3 and 3, and if I multiply them together, well, that is basically just going to equal 1, right? Because 3 and 3 will cancel, and so I just have 1. So when I have 1, well, a to the 1 is basically the same thing as saying just a. So that's how we can get rid of that exponent by raising it to the reciprocal power. So on the left side, I'm going to have a, and then 5 to the third, you can just do that on your calculator. 5 to the third power is 125. So a equals 125. Now you can go ahead and pause the video and try doing this example on your own. So in this one, the rational exponent is already isolated, so we don't actually have to do anything extra to get it by itself. What we need to do now is think about what the reciprocal of 2/3 is. The reciprocal of 2/3 is 3 over 2. So what I'm going to do in this problem is raise both sides of the equation to the 3 over 2 power, and let's see what that looks like. So on the left side, that's just going to go ahead and cancel, so we have x, and so that gives us x equals 16 to the 3 over 2. So let's think about 16 to the 3 over 2. Well, we can rewrite that, and that'll become the square root of 16 to the third. The nice thing about exponents is you can do them in either order. You can do the square root of 16 to the third, or you can do like the square root of 16 and then raise it to the third power. And that's actually a little bit easier to do. You can do it either way because if you have a calculator, you can find the square root of 16 cubed. But I like to do the square root first because what this will turn into is, well, we know the square root of 16 is 4, so we have 4 cubed, which is equal to 64. So you see x equals 64 is our answer. So if you do the square root before you do the cube power, it makes it a little bit easier to solve. So now let's try this example. So you can see here our rational exponent is definitely not isolated, so we need to do our opposite operations to get that term by itself. So I'm going to start off with plus 8 on both sides, right? Because remember, we want to do the add or subtract before we multiply or divide. So I have 3x to the 4/3, and that's equal to 40 plus 8, which is 48. Now to get that term by itself, I need to divide both sides by 3. So when I divide both sides by 3, I get x to the 4/3 equals 16. So now once again, I need to think about the reciprocal of 4/3. The reciprocal of 4/3 is 3/4. So I'm going to raise both sides of my equation to the 3/4 power. So when I do that, on the left side, that's going to leave me with just x, and then I have 16 to the 3/4. Remember, I can rewrite that as the 4th root of 16 cubed, right? Or I can do them in any order, so I can do the 4th root of 16 and then cube that. Well, remember, the 4th root of 16 is actually 2, right? So this is going to simplify to 2 cubed, which is equal to 8, and that is now our final answer. So now you can go ahead and pause the video and try doing this example on your own. So here, once again, we need to do some extra work to isolate that term that has the rational exponent. So I'm going to start off by adding 35 to both sides. And when I do that, I get 5x to the 1/2 is equal to 135. Now I'm going to go ahead and divide both sides of this equation by 5, and that's going to give me x to the 1/2 equals 135 divided by 5, and that is 27. Okay, so now in order to undo that x to the 1/2, I'm going to go ahead and figure out the reciprocal, right? The reciprocal of 1/2 is 2/1, and that is just equal to 2. So what I'm going to do here is actually I'm going to square both sides of my equation, and so that's going to give me x equals 27 squared, and for that you can just use your calculator. 27 squared is equal to 729. So now let's try this word problem. It tells us that the area in square units of one face of a cube with volume of v cubic units is given by the formula a equals v to the 2/3. The area of one face of a cube is 576 square units. Using the formula given, determine the volume of this cube. Okay, so here we have this formula, and it's giving us the area of one face is 576. So let's go ahead and plug in what we have. Since it tells us the area, that's going to be the value of a. So we have 576 equals v to the 2/3. Okay, so now we just have an equation that has a rational exponent in it. So we need to figure out the reciprocal of 2/3. So we just flip it, and that's going to be 3/2. So I'm going to raise both sides of this equation to the 3/2 power. And so on the left side, well, that's basically going to be the square root of 576 cubed. And I really don't want to figure out the square root of 576 cubed, so I'm going to rewrite this as the square root of 576 and then raise that to the 3rd power. And then on the right side, I just have v. Well, the square root of 576 is 24. So this is 24 cubed equals v. 24 cubed, if I do that on my calculator, is 13,824. And since this is a word problem, I need to add in my units. This is going to be units cubed, and that is equal to the volume. Okay, and that is now our final answer. So remember, you can solve an equation with a rational exponent by isolating the term with the exponent. Then you can raise both sides of the equation to the reciprocal power to solve for the variable.